Okay, now I'm gonna try to get into SPSS. See if they'll let me. Can you guys still hear me?
Yep.
Okay.
Which one are we on? 14?
What?
Which one are we on? 14?
Yeah.
Oh, I still need to do the evaluation.
Okay. Can you guys still see me, hear me?
Mhm. Yes, ma'am.
Yeah.
It's already the 9th? Sheesh. Alrighty.
Okay. Can you hear
There are
me?
18, there are 18 questions. Really only 16 because the first two are.
Yes, no.
I know it is. Alrighty, first one. Look at my notes.
Sorry, I'm still getting in. I got into SPSS with you guys on Hangout and recording, so this is amazing right now. Just gonna get into the quiz now.
Okay. I think 3 is true. Because I feel like with the ANOVA tests, most of the time the null hypothesis is that the differences are all means are equal.
Sorry, I'm still not in. I'm almost in.
What?
Dark quiz. Okay, I'm just starting it up.
Okay.
I did it. Okay, yay. Okay.
So 1 and 2, or you can do 1 and 2, whatever you gotta say, and then 3 is true. Pretty sure.
An ANOVA hypothesis test, we reject. When there is sufficient evidence to indicate at least one in the others. Okay.
I'm pretty sure the hypothesis for ANOVAs is always that the means are equal, the null hypothesis. I could be wrong, but I'm pretty sure that's what it always is. At least it looks like that by my notes. Glad I put true. For 4, what requirements need to be checked when performing an ANOVA hypothesis test? There's 2 requirements. The data are normally distributed in each group, and the variances are equal for each group. Number 5. To check if a group is normally distributed, do the following. It says, check by examining the variances. If the largest variance is less than or equal to 4 times the smallest variance, then we will conclude that the variances are blah, blah, blah. Is that going to be in a scatter plot? I think it might be QQ. So I remember
histogram.
What?
I was histogram.
Oh, wait, what is a QQ plot again?
I don't know, but it says.
Oh, a scatter plot for sure. Yeah.
I think it's QQ, but
Really?
I don't know.
I
But
can't
think
remember what that is.
it's because I know that with ANOVAs you have to use the QQ test on SPSS. So I think it's
QQ.
Also, because it has a first and a second. It has 2 data sets. Compares the mean. By quantile, we mean the fraction of points.
I know that 6 is the largest variance is less than 4 times the smallest variance.
The largest variance is.
And did you get all this from the textbook?
Yeah.
Okay.
Sorry, the largest variance is less than 4 times the smallest variance?
Sorry, what?
The largest variance is less than 4 times the smallest variance?
Yeah, the largest variance is less than 4 times the smallest variance. So with the number 7, every pair of samples is matched up together. So if there's 4 samples, shouldn't it be 24 pairs? Because isn't it like when you do, when you did in 5th grade, and it's like you have this many options for pants, this many options for shirts, how many pairs can you make? What you do is like get the number you have total and do like 4 times 3 times 2 times 1 type thing. So I think it'd be 24.
So if there's 3 samples, there are 3 pairs.
Wait, no. So you just...
I thought that would it was just the number squared.
It could be.
Well, it depends on if the order matters.
Yeah. Well, we can try submitting it once with 24 and see if that's...
Okay.
Works. Okay, so the next question we have to use SPSS.
Oh wait, I think you're right though, Michaela, on the squared thing. It sounds familiar to me.
I made it.
Maybe not. I don't know. Okay, so we're trying 24?
Mm-hmm.
I made it.
Okay, shh.
Come on, SPSS. There you go.
Haley.
Oh, Daddy's on here.
They're not here.
Yeah, Daddy's on here.
Take your...
Daddy's at computer, yeah. Selena, do you have your quiz open?
No.
Open your quiz. We're doing the answers.
Ooh.
Okay, 8. Oh, are you guys just getting into SPSS now?
Mm-hmm.
Open.
See, open.
Yeah, do you want to come here? Say hi, Daddy.
I know there's only 4 pairs, but I wrote them all out, but I don't know if that's right.
Okay, we can use it as a guess.
My question is does order matter? Does order change it?
Yeah, because I think order doesn't matter, so I think it is only 4 pairs. Because, comparing 1 to 4 would be the same as comparing 4 to 1, I think.
Hmm.
So I don't think these are differences. I think they're averages. Because if it was differences, then it would matter, but I think it's just means. Anyways, so do you guys have the SPSS up?
Yeah.
Mommy.
I don't know how to do
You do a test.
yeah.
So what you do is you go to Analyze.
Wait, is it just a 1 sample t-test?
No.
Okay. Classify?
Okay. Go to Analyze. Can you share your screen so I can make sure that I'm telling you the right thing?
Wait, can you see my screen?
No.
Oh. Oh. And I have to
We have to do the ANOVA thing, right?
Yeah. So it's Analyze, Compare Means, and then One-Way NOVA.
analyze, compare means. One.
And then data values go to the dependent list, group name. Oh yeah, I think we have to add a group name.
Oh yeah, because look, it only has one thing. Kicking
Yeah, so sorry. Cancel that and go to, I think it's transform.
Okay.
Okay.
Can't really see what that says. I wrote it down.
There's compute variable, programmability transformation, count values within case, shift values, recode into same variables, recode into different variables.
Oh, automatic recode. It's automatic recode.
Okay. Now which one is it?
And then I think it's the footwear. And then put that over there, and then put a new name of like,
Look, the goat is.
Okay, shh.
well, like, so put factor or something. Or is it code? I think it might be.
You have to put like code in caps after it.
And then do you add new name?
You can put it.
And then
You got ear. You got ear.
okay, and then I think if you do the analyze,
Okay, so press OK, and then do analyze.
yeah, analyze, compare means, one-way ANOVA. Okay, so that goes in the dependent list, and then the group name, the factor code, goes in the factor.
Ah, yeah.
And play mom.
And then push OK.
And
Okay.
play this mom.
Oh wait, sorry, go go back to the analyze, compare means thing. There's boxes we have to click that I forgot about.
Oh, okay. Analyze, compare means, ANOVA.
Okay, then go to the options and select descriptive and means plot.
Means plot. Wait, can I just write this down real quick? Okay.
And do we leave it as exclude case analysis by
Yeah, I didn't say to unclick anything.
Next sticker.
Descriptive and means plot?
Yeah,
Okay.
Next
okay.
so
sticker.
it gave us a graph.
Okay, go to the table.
Look. The boys stickers.
I don't know how to find what the minimum variance of the groups is. Would that be like the smallest mean?
Maybe like this minus this. Oh wait, between groups.
Yeah.
So what was the question?
What is the minimum variance for the 6 groups?
So I think oh well this is probably the max.
I think you're gonna have to look at the means up by the this spot above.
These.
Yeah, and I think we're gonna have to. I feel like it would be like the smallest of those.
So it's probably C.
Yeah, so 9.45 maybe.
Yeah.
Mommy.
I got 33.10
Oh, yeah.
What?
for my smallest, for minimum.
Where
Wait,
did you find that? Can you share your screen?
I'm not sure if I can. Okay, so how would I do that in SPSS? Let me see.
You would share your screen through the Hangouts, not through SPSS.
Okay, because I can't see my Hangout. That's the problem.
Okay, well we'll try. Michaela, do you want to pull up the SPSS one more time? And we can look at those.
Minimum and maximum, kicking accuracy, and the minimum is 22 for all groups. I don't know if it's right, but and then the maximum is 44.
Hey.
Maybe it's over on the right side of the table. So, okay, there we go. So the smallest minimum is 19.
Yeah, but we have it twice.
Yeah. Smallest
Huh?
minimum is 19. And the largest is 48.
How large?
Down to 3 decimal places is what confused me. But
Oh yeah. Hmm. That is a good point.
I wish it said like it was labeled better because it just says like minimum, maximum, minimum, maximum.
Ooh, guys. This says variances for each group can be found in the descriptives table under the QQ plot.
Okay, in the descript where?
Oh, I guess the descriptive table it looked like was at the top.
Look
You just
here.
passed it.
Look here.
Okay.
I don't think it's under the Q coupon on this, but I saw a descriptive table. So I guess, yeah, the minimum is 19.
Maximum's 48.
I can't see it. I don't see it because she's on the left side of it.
Look, stickers.
I guess what we could do is submit 19, and then if that doesn't work, we can try the 19.45.
Yeah.
And then if that doesn't work, then we can figure something out.
Here he goes.
So number 10 says a test for equal variances is satisfied for these data. I think that's true because it tests if the variances are equal. They're not, but I think it's true that it tests for them. You know what I mean?
Construct a QQ plot.
Okay. Oh, wait, guys. So now it's telling me we have to go look for a QQ plot. Maybe that's where we'll see the minimum and maximum variances.
Okay.
So go to Analyze, Descriptive Statistics, QQ plot. Or wait, no. Sorry. Sorry about that. Revert. Analyze, Descriptive Statistics, Explore, and then
Hey.
click on Plots
Oh, we hide it.
and mark Normality Plots
Wait, where's the game?
and push Continue.
Oh, normality plots? Okay.
Yeah, and then the dependent list will be the kicking accuracy,
There you are. There you
and
are.
the factor list will be the factor code.
You are.
Okay, wait, hang on. Dependent list is what?
This.
The kicking accuracy,
Okay.
It's a
and
win.
factor list is factor code.
Okay, and how do you...
You win.
Oh, okay. I
You
get that. Okay.
win.
And label cases by or no?
I don't think so. I didn't write anything down about that.
Yeah, too.
Okay, shh.
I think it whoa, my gosh. It just gave me like it just did like it in like every graph.
Hmm.
Well, it says construct 6, right? So, yeah, it did give a lot of graphs.
Okay, well let's see. I have like
Construct a QQ plot for each of these 6 samples. Each of the samples are approximately
oh, so it has the variance on here.
Where's that? Where did you find that? Here's a QQ.
Go all the way up to descriptives. So there's 27.358, 20,
What's wrong game? What's wrong game?
Okay, shh.
27, 53, 31.
So 53 is going to be the greatest, right?
Yeah.
What is it exactly?
It is 53.158.
And then what was the lowest?
One sec.
Wait, I'm still trying to find this. Sorry.
Dang it. Okay, and so the smallest was what was okay, 27. Okay, so the smallest is going to be 27.208.
Okay. Michaela, if you want to keep yours up, I can read them to you after.
Okay.
That'll be easier on you, not have to flip between them.
Oh, okay. I'm finally seeing the variance thing. Okay, 27.208.
So I guess that for the it says each samples are approximately normal based on what you see on the QQ plots. Well, to be normal,
I think being normal means it stays close to this line, so I think they are.
Right. As it stays close to the line, it's normal.
but do all of them stay close to the line?
I don't know. Let me see.
See, I don't think they all stay as close. Some of them have a few outliers. Yeah. I
If
think
there are a few outliers, then it can't be normal.
Yeah, and I think it's not going to be normal because
I mean, either way, we only have two
because of
options.
how different the maximum and minimum variances are.
Yeah, either way, we only have two options, so we can always.
What was the maximum on the variance?
It was 53.1.
0.11?
158.
158. Okay.
Okay, so number 12 says perform an ANOVA test with SPSS and observe that the p-value is 0.081. So do you want to go back to the regular ANOVA test?
Which one is that?
Go to...
This one? Normal? QQ plot?
No, we're in the QQ plot one, so if we do the analyze, compare means, and one-way ANOVA.
Oh, so I can just go back up to the one we already have.
Oh,
This one.
okay.
Oh, so the p-value is 0.81.
Do you see that p-value on a table, Michaela?
The SIG?
Yeah. Okay, there it is. So
Yes.
get rid of the socks.
Remove the sock data and perform test again.
Okay.
So what do we do? Analyze. Just
Can you go back to that table before you get rid of?
It won't get rid of it, it'll just.
make a new one.
Okay, because the F we're gonna have to need for 13. So I just saw it and I didn't want to lose it.
Okay, so it's descriptive, or compare means, one-way ANOVA. So what am I taking out of here?
Yeah, how do you take the socks off?
How do you knock the socks off?
I don't know.
We must have to go back to that first thing when you were transform, maybe?
I don't even know if this has. Oh, wait, here's
Like,
socks.
don't highlight socks and highlight the rest of it.
Automatic recode.
I don't know if it does that, but I can try.
Did you try deleting all the socks? Does it let you do that?
Yeah, I can, but should I?
Well, I don't think there's any more questions regarding those stuff.
Okay.
The next
Wait, how do you-
questions are going to be with a different type of test, a different data set.
Here, I'll delete them on mine. There's a lot of socks. Okay.
Oh, whoops. I'll just cut them, and then if we need them again, I can just copy them back in.
You like it?
Yeah, clear it out.
Already.
Analyze, compare means. Okay. So the p-value now is 0.309, but the f-value did change with this one. So,
Yeah, I would just go with the regular one.
Okay.
And all it's asking is about a general thing. It's not asking for the actual F. It's saying, is a p-value the area up to the right or the left of the F statistic? And my notes from the textbook say the p-value for ANOVA test is the area to the right tail. To the right?
So is it 0.309?
Yeah.
Okay. Did you hear that, Glenn?
So is it right, you said?
Yeah.
Oh, okay. Can you re-say that, what you said one more time, just so I can write it down in my notes?
Yeah, the p-value for ANOVA test is the area in the right tail.
P-value for ANOVA test.
I did what I passed by. Good job.
The area in the right tail?
Yeah,
Thank you.
you're welcome.
Okay.
Mm-hmm.
14?
Yeah.
Okay, so now we're doing a new one.
We got the meat.
Right?
Hot dog. Oh,
Did you say hot dog?
hot dogs, isn't that what we're doing?
Yep.
Sick. Okay.
Come hang out with me whenever you want. Okay. Right now. If I get my homework done.
Okay.
Okay, so analyze.
Wait, do we have to transform first or no?
I think so.
Automatic read through?
Well, I don't know because
You have to change this type one into something that can be put in the factors list. You have to put type with code at the end.
The factor?
Yeah.
Okay.
And then put type code.
Right.
oh my gosh, guys, I'm so tired. I went to bed at like 5 in the morning this morning just because I just couldn't sleep.
Ugh.
I was like, this is dumb.
I already did the humanities quiz without Stetson, and I'm just going to try to help him do it because I didn't want to have to wait till he gets home from work. And then try to do it because I'd be too tired.
Yeah, I haven't done my anatomy quizzes yet because I'm too tired.
Alrighty, so if you want to do the thingy again.
Compare
That
means.
means one way ANOVA.
Okay, so dependent list, do we put calories and sodium over there?
Yeah.
Okay, and then factor is factor.
Yeah, the type code.
And then options is descriptive
Oh,
and
yeah.
Oh, wait, let me see if I have to do that again.
means plot.
Yeah, descriptive and means plot.
Okay, so what are we looking for?
First we're looking at if we can assume that the variances are equal, and if we can assume that the population is normally distributed.
Okay, so I didn't get the variances until we did that one thing last time. What else did we do when the variances came up finally?
We did the QQ plots.
QQ plots? Let's do that again.
Dependent list was
Calories and sodium. And then factors type code. And then click plots. And click normal.
Sorry,
add.
factor list is factor, but what do you do with type?
Don't do anything with it.
Okay, sorry.
Okay.
Okay, and then we want
a
We
billion.
want to look at these QQ plots and say if we think that it could be normally distributed and the variances are about equal.
So do we do anything under under plots on this section or no? Like, do we add? You know when it says like options, do we have to add anything in there or?
So wait, for plots.
Okay, variance is totally not equal. Just so you know.
All right, so.
There were pies.
Variances.
Donut. That's what I want.
So can we assume that the groups are normally distributed or no?
No. Look at these. Look at these graphs.
Yikes. So I'm going to put that the assumptions have not been met. While it is safe to assume each group comes from a normally distributed population, we cannot assume that the variances are equal.
Yep, that's what I was looking at.
All right.
Which one is it?
Okay. I'm itchy. That's number 14. It's the second one.
Okay.
And then for 15,
I can pull up the ANOVA test.
I think it's going to be the third that they have different means. Because if you look at the degrees of freedom, they're so far apart that I think that they're going to have. I think it's going to be the third choice, but I don't know.
We'll see. Hey, almost there.
You should see that the QQ plot for poultry suggests a possible problem with the normality assumption. The smallest variance is blah blah blah, and the largest is blah blah blah.
Mm-hmm. So this is one here. So which beef, meat, poultry? Here we go. Do you need
Okay,
to see
so
it?
let's see. Hold on. I'm going to try the 10.92.871 divided by 4. So the largest variance is less than or equal to the smallest variance. So the variances are going to be equal, but it says that there's a problem with the normality. So I think that it's going to be the assumptions have not been met. It is not safe to assume that each group comes from a normally distributed population, but we can assume that the variances are equal. So the third one.
Okay.
Even though the variances didn't show up equal on that other test.
Well, the variances don't have to be like the same number. They just have to have like the largest being less equal to or less than.
Okay.
Smallest.
Okay. Gotcha.
Alright, 17. Despite the possible problem with the QQ plot for poultry, we decided to use ANOVA to determine if the mean sodium levels are the same for all three groups. So what is the p-value for the sodium? So we need to do just sodium. Sig.
But each one has a different p-value.
So just sodium?
Yeah. Like beef, meat, and poultry each have a different one.
So did you guys delete out the other ones, or?
No, it's still on here.
Do you want to try doing another ANOVA test with just the sodium?
Yeah, that's what I was gonna do.
Would I have to how would I do that?
Just the sodium of
Okay, so
Oh,
put
take out
calories.
the sodium. Delete the calorie column.
Okay. So the p-value is going to be 0.179.
Okay. 179. Conclusion can you draw about the mean sodium levels of these three types of dogs? Okay, so it is
Value is greater.
So the p-value is greater than the level of significance. So if the p-value is greater than the level of significance, then you are going to
Did you get 0.179?
fail to reject and not sufficient evidence. So
Not sufficient evidence to reject the claim.
we do not.
Oh, there's only one that says we do not have sufficient evidence, so that makes it easy.
I feel like that's worded weird. Oh, but yeah, okay.
Okay, do you guys want me to submit?
I'm gonna submit mine,
Okay.
and then I'll tell you guys how we did.
Glenn, did you get all the answers there? I think we're on mute.
Got it 80. And
Oh.
it gave us the answers.
Yes!
Hallelujah!
I knew I was
Alright, y'all. So let's go through this.
Which ones did you end up putting for the variants?
What's numbers of those?
8 and 9.
27.208 and 53.158.
And were those right?
Yeah, they were right.
Yeah, now we know how to do it.
I don't remember how you found that though. For
What's wrong? Which ones are wrong?
okay, hold on. Okay, so the ones that are wrong are number 7. The answer is 6.
Oh,
And number 11, the answer is false.
Oh, that's what I had.
I mean, sorry, the answer is true. The answer is true.
Oh, okay.
Blah, blah, blah. I was reading which one was wrong. Number 14, it's the second one that says the assumptions have not been met. While it is safe to assume each group comes from a normally distributed... That's the wrong one. Oh my gosh.
I was like, that's the one I have selected.
Ah! Sorry, guys. The assumptions have been met. It's the first one. It's safe to assume each group comes from a normally distributed population, and we can assume that the variances are equal. Number 15 is also wrong. The correct answer, I'm double checking that I'm looking at the right one. The correct answer is we have sufficient evidence to claim that at least one of the hot dog types has a different mean number of calories than another type.
So the last one?
Yeah.
wait.
So
So
you're
the
like pretty much right.
last
We
one?
thought that all of them are different.
Did we get
That's all that's wrong. The rest of them are right. So I can go through and read them to make sure you guys have the right one selected.
Okay.
Okay. True. Data in each group are normally distributed and variances are equal in each group.
Oh, wait. Hold on.
Oh, sorry.
Touch it.
Okay.
What did you get?
What the heck?
It's here.
You have another tab open?
It says I've submitted it twice already. I've only submitted it once. Oh, there we go. I was like, excuse.
And
Oh
still
my gosh, it won't let me take it.
apple.
Yeah, Apple Day keeps the doctor away.
There we go. Please work.
But the tooth is sticky.
Okay. So true, then what? The next two?
Number 4 is data in each group are normally distributed and variances are equal in each group. Number 5 is construct a QQ plot for each group. And then the largest variance is less than 4 times the smallest.
706, right?
706.
Get that out of your mouth. Do not put those in your mouth. Get it out of your mouth.
But
Okay, and then number 8 was 27.208. Number 9 was 53.158. Number 10 was true. Number 11 was true.
Number 11 is true?
Yes.
Oh, why did I have false? Okay.
Because that's what we selected before, but it was wrong. Number 12 is 0.309.
We're gonna go back.
13 is right. Number 14 is the first one. The assumptions have been met.
5 minutes or something, and then you have to have a
Okay, number 15 is the last one. We have sufficient evidence claim that Sorry.
When?
Okay, 16 is the assumptions have not been met. It is not safe to assume each group comes from normally distributed population, but we can assume that the variances are equal. That's number 3, like the third one.
It's a third one?
Yeah.
Papa, go.
No, it's not Grandpa. It's the neighbor.
Okay, number 17 is the 0.179, and 18 is we do not have sufficient evidence to reject the claim that all 3 hot dogs had the same mean sodium levels.
Okay.
Okay.
That's done.
Okay, Michelle, do you want to stop the broadcast and post a link real quick before I forget to fill it out?
Yeah, hang on. It's gonna take me a second to get out all this SPSS stuff.
Alright.
Log off.